So you got yourself some C3H8O2. Well, that doesn't tell you much. There's probably all sorts of molecules that correspond to that formula. We really need to draw bond formulas if you want to have a detailed understanding of what you're talking about in terms of substances. So let's learn how to draw structural formulas and skeletal formulas. These are two different representations that give you a lot of detail. I like skeletal formulas. You'll see it's a nice shorthand way to draw things quick. This is a structural formula shown here, and in fact if you add them up you'll see this is C3H8O2. Notice we have bonds, but notice if you're looking deeper that we have these wedge-shaped bonds here and what they call these hatch-shaped bonds here. They're trying to show you some stereochemistry here. So, bond formulas, screencast 7.10. Alright, so let's try drawing some molecules, and I'll show you both the structural formula and the skeletal formula. The skeletal formula is going to look weird at first, but with time I think you'll come to prefer it. C3H8. Is there more than one way that can be drawn? I think not. I think if you play around and recognize the carbon always forms 4 bonds and hydrogen 1, there's only one way you can do it, and that's by just drawing the carbons as a skeleton. I'm sorry, as a backbone here, and throw your hydrogens around it. Notice every carbon has 4 bonds. Every hydrogen has 1 bond. So it's a simple game to play. It gets tedious to draw all those hydrogens. Imagine, C40H82, that kind of thing. And people start just drawing zigzags like that. That means the hydrogens are implied. Now, most common error, people don't realize that the end of the line is a carbon as well as the bend. So write it if you need to. Ends or bends of the line are carbon. Hydrogens are implied. If there's something kicking around other than a hydrogen, like say an oxygen or a nitrogen, they'll just go ahead and throw that in there. If it's a functional group, like an alcohol or something like that, they don't have to, but they usually throw it in also. So they'll show an OH, even though that H could be implied. They'll do it because they want you to really emphasize there's an alcohol there. That might come up for this one. Try to draw C2H6O 2 different ways. There's only 2 ways it can be drawn. Remember, 4 bonds for carbon, 1 for hydrogen, and 2 for oxygen. Honk if you love chemistry. You should memorize those. I'm going to pause it. Or you should pause it and go ahead and do it. And I really hope you do. You should get this. There's one of them. And did you get the other one? It's that one. There are no other ways this can be drawn. You might draw the oxygen over on this side, but that's just a flipped over representation of the same molecule, not a new molecule. Okay, so there are the structural formulas. Let's draw them as skeletal formulas, and that means just dump all those hydrogens. No hydrogens, except maybe this one right here to show a functional group. And there it is for this dimethyl ether molecule right here. You'll later learn that this oxygen in the middle means an ether. In case you're curious, this thing is used sometimes as an anesthetic. It knocks you out. This molecule will just about knock you out if you drink enough of it, but you'll get a wicked headache in the morning. And this is ethanol, perhaps the most abused molecule on planet Earth. And there's its chemical structure. Notice they drew that hydrogen anyhow just to be nice. That's called an alcohol functionality. Alcohol, ethanol. Let's try another one. Here's a random isomer of C3H6O2. Is that right? Yeah, and the first slide, I think it wasn't C3H8, was it? It was C3H86O2. Anytime you have a ring, you lose two hydrogens, and I forgot that. But there it is, C3H6O2. And there it is as the skeletal formula. Dump all the hydrogens except those that are in a functional group, and that's it. Wedge means coming out of the plane of the board, of the plane of the, well, in my case, this laptop, and the other one's going in, so this bottom one's going in. Do you get that? Just like, the perspective type drawing. It's getting close to you, and this one's fading into the distance. Screencast 7.10.